GCE Advanced Level Chemistry Practical Series, Experiment number 5. Experimental determination of a molar volume of a gas. In this practical, we are going to produce oxygen gas through heating of potassium permanganate. And we are going to learn how to collect oxygen gas or how to collect a gas in a laboratory setup and how to measure the volume of a gas. Afterwards, using this experimental data that we gather, we are going to calculate the molar volume of a gas under laboratory conditions. Now, let's move on to the reagents and equipment we will be using for this practical. In this practical, we will be using potassium permanganate as our only reagent, and apart from that reagent, we are going to be using all of these equipment. We have here a measuring cylinder. We have here what is known as a Wolf's bottle, or sometimes referred to as a wolf bottle, and we have a boiling tube. It is connected to a retort stand, and we have a spirit lamp. We have small amount of cotton wool. We have a thermometer, and we have a digital balance. In this experiment, we are going to be using this setup. Even if you take a look at your practical textbook, we have the following setup represented to you as a diagram. As mentioned in the introduction of this video, we are going to be using potassium permanganate, and we are going to heat potassium permanganate in this boiling tube that we have here with the use of our spirit burner. And when potassium permanganate is undergoing thermal decomposition, it will be producing oxygen gas. And the oxygen gas that is produced is going to be collected with the help of a wolf bottle. What we have here is referred to as wolf bottle or wolf's bottle. And when the oxygen gas produced in this boiling tube comes through this tubing that is connected to the wolf's bottle, when oxygen gas collects here, amount of water that is equivalent to the volume of the oxygen gas is going to be transferred through these tubings into our measuring cylinder. Now, this is a 1000 milliliter measuring cylinder. When we are doing this experiment, we are hoping to collect close to 400 milliliters of water, which means we are going to be collecting close to 400 milliliters of oxygen gas as well. While conducting this experiment, we will be using the following equipment as well. To measure the room temperature, we will be using a thermometer. We will be using small amount of cotton wool, and we will be using a digital balance as well. Now, let's move on to our practical. In this practical, we will be using potassium permanganate as a reagent. We will take potassium permanganate, and with the use of our digital balance here, we are going to be measuring around 5 grams of potassium permanganate, and we will transfer that into our boiling tube we have here. We can see the boiling tube is fixed onto a retort stand so that it is held in place or secured in place. And we will be heating the potassium permanganate in the boiling tube with the use of this spirit burner. When we are heating it, sometimes small solid particles can also get carried away due to the heat into this tubing. To prevent that, we will be using a small amount of cotton wool that we have here, and we'll be inserting a piece of cotton wool here to make sure that all the solid particles are entrapped in the cotton wool. And then you can see this boiling tube is connected to the apparatus that we have here. This is known as a wolf bottle. It is connected through rubber tubing, and each of the rubber tubings is connected to the boiling tube and to the wolf bottle with the help of a rubber stopper, making sure a perfect airtight seal is made with the use of a rubber stopper. So when potassium permanganate is heated, due to thermal decomposition of potassium permanganate, oxygen gas will be produced, and that oxygen gas will travel into the wolf's bottle, and when that oxygen gas is collected here, an equivalent volume to the volume of the oxygen gas that is getting collected here will get displaced into this measuring cylinder. You can see there's another tube connected to our wolf's bottle, transferring liquid into our measuring cylinder. When the reaction is taking place, we are hoping to collect around 400 milliliters of water, which means an equivalent volume of oxygen gas will be collected here in our wolf's bottle. Without further ado, let's move on to our practical. First, we have to measure 5 grams of potassium permanganate. In order to do that, we will be using our digital balance that we have here. As always, when starting off, we have to observe if the balance reads 0 and if the measurement unit is grams. So we can see the balance reads 0 and the measurement unit is grams. And then we have a dry, clean boiling tube with us. We are going to place it on our digital balance, and we are going to tear the reading of the digital balance. Now, on this balance, the mass of the boiling tube is disregarded, and to this boiling tube, now we are going to add 5 grams of potassium permanganate. We have our potassium permanganate here. Let's carefully add 5 grams of potassium permanganate into our boiling tube. So now we have measured 5.09 grams of potassium permanganate into this test tube. We need to note down the mass of potassium permanganate we have measured, and we are going to now move on to the next step, which is including a small piece of cotton wool on the upper part of our boiling tube. This will prevent any solid particles from entering the next part of the setup. Now we have placed our cotton wool around the top portion of our boiling tube. This will act as a filter, entrapping any solid particles that may try to move on to the next part of our setup. Due to the heat that is produced here, sometimes certain solid particles can get carried away into the next part of the setup if we do not have this cotton wool piece lodged on the upper end of our boiling tube. Now, after doing so, we need to again measure the entire mass of this boiling tube. When we are doing this, we have to make sure digital balance reads 0, and after making sure that it reads 0 again, we are going to place this entire boiling tube along with potassium permanganate and the cotton wool piece in it. We are going to note down the mass of the boiling tube, including the potassium permanganate and the cotton wool piece in the boiling tube. So the mass of the entire setup here is 34.40. This includes the mass of the boiling tube, potassium permanganate, and the cotton wool piece. Now, we are going to fix this boiling tube into our main setup. Now, we have included the boiling tube that we measured the mass of in the previous step in this particular setup. You can see here now that boiling tube is connected to our retort stand and is integrated into our setup. When we light this spirit burner, it will heat up the potassium permanganate that we have in the boiling tube and will produce potassium manganate, manganese dioxide, and oxygen. Out of these three products, the only gas that is produced is oxygen. So, when oxygen gas leaves this boiling tube, the overall mass of the boiling tube will be reduced. So, after the entire experiment is over, if we measure the mass of the boiling tube, we can calculate the mass of oxygen that left the system. Therefore, through a calculation, we can identify the amount of oxygen gas that was produced in grams. The oxygen gas that is produced will come and get collected into the wolf bottle. An equivalent volume of water will be displaced due to the oxygen volume that is getting collected over here in our wolf bottle. Now, let's start our experiment by lighting this spirit burner. We have started our experiment. So after a while, you will notice water is getting transferred or displaced from the wolf bottle into this measuring cylinder. You can already see water going up this glass tube and onto this rubber tube, right? Which means the reaction has already started and oxygen gas is already getting collected in this wolf bottle here. You can see water is going to be displaced onto this measuring cylinder. You can see drops of water coming into the measuring cylinder now itself. Mere seconds after starting the experiment, we can see water being collected onto our measuring cylinder. We will allow this experiment to continue until around 400 milliliters of water is collected. After that, we will stop this reaction. We will measure the atmospheric temperature and we will measure the mass of the boiling tube after the reaction has gone to completion. We have the mass of the boiling tube before we started the reaction, and then we will measure the mass of the boiling tube after we have conducted the reaction. The difference between the two will give us the mass of oxygen that is produced. And the volume of oxygen that is produced can be obtained with the help of this measuring cylinder. You can see that water is being displaced into this measuring cylinder, and the volume of displaced water is equivalent to the volume of oxygen gas that is collected here. Students, we have now removed our spirit burner from the setup. Now it is no longer used to heat up our potassium permanganate sample that we have in our boiling tube. We have collected close to 500 cubic centimeters of water through displacement of water. We are going to let the system settle down for a while, and then we'll come back and measure the volume of the water that is present in the measuring cylinder clearly. Now, we have allowed the system to cool down for a while. Before we move on to measuring the final volume of gas that is collected, I would like to bring your attention to the boiling tube that we have over here. If you focus on the boiling tube, we can see that we only included the solid over here at the bottom of the boiling tube. But as we subjected this area to heat, we can see some solid particles have started moving upwards, and it has only stopped due to a cotton wool piece that we have lodged over here. Due to the cotton wool piece we have over here, the small fine solid particles that were traveling upward did not get introduced into this tubing, meaning the solid particles remained in the boiling tube itself, and therefore it did not interfere with the weight loss that happened due to the formation of oxygen gas. So whatever the weight reduction that you will observe from this point onwards is purely due to the emission of oxygen gas from that sample. Now, let's move on to measuring the volume of oxygen gas that is produced. Before we do that, we can see over here the water that we had in the wolf bottle has been transferred into our measuring cylinder. Before we take the final reading, we have to make sure that the two water levels in both the wolf bottle and the measuring cylinder is equal to one another. In order to make sure that the water levels are at the same level, we have to bring the measuring cylinder closer to our wolf bottle. We'll try to bring the measuring cylinder as close as we can to our wolf bottle over here. Now, we have brought the measuring cylinder and the wolf bottle close to one another, and you can see the water levels of both the apparatus is at the same level. So, at this point, we can be sure the air pressure inside the wolf bottle is equivalent to the pressure that we have here on the surface of our measuring cylinder. On the surface of the volume of water that we have in the measuring cylinder, the pressure they experience is atmospheric pressure. So we can be sure that whatever the volume of gas that is present inside our wolf bottle is also experiencing the same pressure. Now, all that is left for us to do is transfer the volume of water that is trapped inside this tubing. the volume of water that is trapped inside this tubing should be transferred into this measuring cylinder. You may ask why that is. That is because when we initially started this experiment, this tubing was filled with only air. Now it is filled with water, indicating when water was being displaced, some amount of water was spent in filling the volume of the tubings that we have here. That should be accounted for when it comes to calculating the volume of oxygen gas that is produced. Earlier on they were filled with air, now it is filled with water, which means it should be added on to our measuring cylinder over here and should be taken into account when measuring the volume of oxygen that is produced. After making sure the two water levels are at the same level, we can now remove this rubber stopper and transfer all the water that was present in the rubber tubing into our measuring cylinder. After transferring all of the water that was present in the rubber tubing into the measuring cylinder, we can now take the reading. The measuring cylinder reading is at 480 milliliters. We have collected 480 milliliters of oxygen gas here. Therefore, 480 milliliters of water was displaced into our measuring cylinder. We have the volume of oxygen gas at room temperature and 1 atm pressure. However, we still do not know the room temperature. Let's take a look at the temperature at which we conducted this experiment. We have our thermometer here. The room temperature, according to the thermometer, is 26 degrees Celsius. The room temperature, according to our thermometer, is 26 degrees Celsius. Thermometer reads 26 degrees Celsius, indicating the room temperature is 26. Afterwards, there is only one measurement to be taken, that is the mass of the measuring tube after we have completed our reaction. So, let's take a look at our boiling tube here. Let's take out our boiling tube. As you can see, we have entrapped a lot of solid particles with the help of the cotton wool piece we lodged on the upper parts of our boiling tube. This ensures that the weight loss that happens in this boiling tube is purely due to the formation of oxygen and oxygen leaving this boiling tube. Now, let's take our digital balance. We are going to weigh the final mass of this boiling tube and its contents. We'll place it on the scale. You can see it reads 33.81 grams. So the final mass reading of this boiling tube and its contents is 33.81. So the difference of the initial mass of the boiling tube plus its contents and the final mass and its contents will give us the overall mass of oxygen that was produced. Now, we have all of our readings needed to calculate the molar volume of gas at laboratory conditions. In our next session, we are going to take a look at the calculations and the important theory parts revolving around this practical.